f of x equals x minus 3, x minus 3, x minus I. If one of the factors is x minus I, what has to be another factor? X plus I. Good. Those come in pairs. Okay, we did two of these last time, so here's the third one to remember how you do them. These are factors. Those parenthesis sets, they're factors. How many x's are there? 4. So if we times everything through, we'd eventually get x to the 4th power, which means it's not quadratic, it's not cubic. What's a 4th degree? Quartic. Okay? Quartic. By the fundamental theorem of algebra, any polynomial with degree n has to have n roots. So if we have the 4th degree, we have to be able to find 4 roots, or zeros. If these are factors, how would we go through and find the zeros? The zero property. Do a little squiggle. Brian, are you with us? Your notes from last time? Okay, set each of them equal to 0. Oops, yep. Oops, nope, did that wrong. X minus 3 equals 0. If x minus 3 equals 0, what's this root? X equals positive 3. And this one, x minus 3 equals 0. What's this root? X equals positive 3. Interesting. If we set this one equal to 0, x minus I equal to 0, what's this root? Yeah, positive I. And x plus I equal to 0, what's the last root? Negative I, so it's just the opposite sign, right? Okay, do you see anything interesting about those roots? They're what? 2 of them are the same, 3 and 3. That's called a repeated root. Okay? 2 of them are the same. So, our roots are x equals 3, and we have plus and minus I. But we have what's called a multiplicity. This is a repeated one. How many times is it repeated?
2.
Yeah, there's 2. Well, yeah, there's 2 of them. So we call it multiplicity of 2. So we would say...
Good morning, college. Here with your morning announcement. So, Interact Service Club is sponsoring a winter clothing drive for the Youth Resource Center of Utah. For homeless teens, you can bring the following items such as coats, hats, gloves, blankets, and or sleeping bags. You can bring a donation to room 217 or designated boxes around the school. Come to Mr. Millar's room after school on the 10th at 2:30 to join Cottonwood's rugby team. That is December 10th to join the rugby team at Cottonwood. Come join the character club and help end bullying in Cottonwood. We provide a safe place for everyone, and we also get to have lots of fun. We meet every Thursday during lunch in this room that is from 2:37. Hope to see you there. Bring yourself and your friends. Come make a difference in social life. Girls basketball team is doing canned food drive for Tough Food Things this month. If you would like to donate and help feed the hungry this holiday season, bring your canned food items to room 212. There's a girls basketball game tonight at Oregon High School. Varsity tip off at 5:50 p.m. Come out and cheer on the ladies for the ladies' home. Senior students who are looking for a great job to pay for college after high school should go to room 110 during lunch on December 10th. ARUP is voted one of the...
Okay, we'll continue when they're done with those announcements. Alrighty, so if we have a duplicate, that's called a multiplicity. So there's really only 3 distinct roots. The positive 3 and plus and minus I. Those are the only ones that are different, right? So 3 is a repeated root, multiplicity of 2. So one thing to note, we're going to look at the graph here in just a second, but when it's an even multiplicity, it's repeated an even number of times, it only touches the x-axis. It doesn't cross the x-axis. If it was repeated 3 times, an odd number of times, then it could cross. Okay? So do y'all have your calculators? We're going to graph this polynomial here up in purple, f of x. Well, oh, actually, we need to do one thing before we graph it. I apologize. We actually need to find the standard form because we can't really type in I into our calculator. Okay, so we've answered, identified the zeros. Which ones of these are x-intercepts? The 3. So our x-intercepts happen at x equals 3. And it happens to not cross, but it does touch there x equals 3. The imaginary zeros aren't going to cross or touch the x-axis. Now we need to find standard form. Okay, so I'm going to rewrite it because this is going to take some distributive property. We need some room. X minus 3 times x minus 3 times, what was it, x minus I? Yeah. Minus I, x minus I. If you remember from last time, I told you, working with the conjugates, you should do those first, because conjugates are really nice, and those middle terms end up canceling out, yeah? Oh, thanks. Yeah, otherwise it's not a conjugate. Yep. So one of those has to be plus. Okay, so I'm going to start with the conjugates. I'm going to just look at those 2 first. What's x times x? X squared. So I'm going to put this in brackets because it's going to be times to everything else on the left. X squared and x times I. A positive xi. Negative I times x. Would you please make sure you're writing this down? And negative I times positive I. Negative I squared. Does anything cancel? Yeah. The middles cancel. And if they are conjugates, you should expect to see that. So we get x squared minus I squared. But what is I squared? So this is minus a negative 1, which means plus 1. See, that came out really nice. Okay, now I'm going to work with the binomials here on the left. Now I'm going to look at these 2. What is x times x? X squared. X times negative 3. Negative 3x. Negative 3 times x. Negative 3x. Negative 3 times negative 3. Do the middle terms cancel? No. Okay, I'll give you a second to get caught up. Middle terms don't cancel, but we do have like terms. If we added those, how many x's would there be? Negative 6 x's plus 9. Okay, we're almost to standard form. How would we continue? That would be to find the x-intercepts. Distribute this trinomial to the binomial. Would you go through and try that, please? Distribute the trinomial to the binomial. Now, if this has 3 terms, and we're timesing by something that has 2 terms, how many terms should you end up getting? 6 terms. So when you go through and distribute, make sure you get 6 terms, and then there'll be some that will combine. So if you get less than 6, then you've missed something. Also, we've already discussed how there were 4 x's, so you should end up getting an x to the 4th power. Okay, Connor, more? What'd you get? To the fourth? Yeah, okay, so I'm just trying to decide which order you've done this in. So you basically took the binomial and distributed the binomial in. Is that what you did? Okay. So x, okay, and then you took the x squared and distributed it in there? Okay. So negative 6x cubed, and then what? X squared times 9?
Without, I thought you wanted to simplify.
Yeah, not yet.
9x squared.
Plus 9x squared. Okay, so that's distributing the x in. And then we need to distribute the 1 in. Okay, keep going, Connor.
Plus x squared.
Okay.
Minus 6x.
Okay. Good. Does that make sense? Then we have some like terms. I think that's the only set, right? X to the fourth minus 6x cubed plus the 10x squared minus 6x plus 9. Is that in standard form, meaning decreasing in power? Oh my gosh, hi. How's it going? Are you in a dance number? Okay. So this is standard form, which is what we want to type into our calculator to see what the graph is looking like. So once you have that written down, grab your calculator. Let's go to y equals and type that in. X to the fourth power minus 6x cubed plus 10x squared minus 6x plus 9. Alrighty, that's in y equals. How many zeros did we say there were? There were 4, but only 3 distinct ones because we had a multiplicity. So if you hit graph, I don't know what my window, oh, it looks like my window's standard. Let's see if we can see all of them. I'm going to fix my window just a little bit. Let's go, it's more of the y's I want to see. -2 to maybe 20. There we go. Do you see the turns? It starts coming down, and then there's a little turn, and then a turn, and then a turn. How many turns do there end up being? 3, because we have 3 distinct roots. Only one of them touches the x-axis. Which one's touching the x-axis? The 3, right here, positive 3. When we get a real root, it's an x-axis, and it's because it was an even multiplicity, we said it wasn't going to cross the x-axis. If we had an odd multiplicity, it's going to go past the x-axis all the way through. But this term and this term, when we have terms that are not touching the x-axis, those would be from your imaginary roots, your complex roots, okay? So this is what a cubic function looks like. It actually almost looks like a quadratic, just with some little squiggles in the middle of the U shape. Even functions look like U shapes with squiggles in the middle sometimes. Alrighty. Any questions on this example we just did? Finding the zeros, finding which ones are actually x-intercepts, and standard form. Yes, Maren? Would you hit y equals? Is the equal sign highlighted? Is there a plot highlighted? Okay. That's usually what's wrong, but okay, we're going to do one more example. That's different directions. Oh, yeah, we just need to fix your window. So I'm going to put it to, what did I do on mine? I think I did -2 to 20, scaling by 2, and then I could see it. Maybe it's not typed in right. Oh, right there. You put times instead of plus. So that if we change that to plus, let's make sure everything else is right. Yep. There you go. All good. Alrighty. One more example. So, example 9. This is like the last problem we ended with last time. So the directions last time were given the zeros, write the standard form. Write the polynomial in standard form. Whose zeros, include x equals 1 and x equals 1 plus 2i and x equals 1 minus I. How many zeros are there?
3.
There's 3 written. How many zeros are supposed to be there?
4. 5.
5. Why is it supposed to be 5? What was your essential question at the beginning of the notes? We have a 0 of a plus bi, then what must exist? Its conjugate. Does 1 need a conjugate? No, that's not a complex one. So even though they don't give it to you, you have to have an understanding that this guy has a conjugate. What's the conjugate? 1 minus 2i. That 0 must also exist. We had a theorem we read last time. If complex 0 exists, its conjugate also exists. Does this one have a conjugate? Yep. So x equals 1 plus I. We have to remember the conjugates. Okay, so polynomial form, when we write our f of x, we actually have 5 zeros. If this is the 0, remember we're going backwards. We need to write the factors. Let's see. Oops, not that one. This one. And the last problem we just did, these we start with in parentheses, the binomials, those are factors. And then we found the zeros by using the zero property. So we're going to be reversing that. If the 0 is 3, the factor said x minus 3. So are those the same signs? Are they the same signs? 3 and minus 3? No. So when you're going backwards, where's my problem? It's gone. Oh, it's down here. Okay. If my 0 is x equals 1, what's the factor? X minus 1. Okay, now these ones it gets tricky. This one is a positive 1 plus 2i. So the factor would be x, and it was a positive 1. So I'm going to put minus 1 plus 2i. X, positive 1, so I put, for the 0, if the 0 is positive 1, the factor would be x minus, but you have to put this all in parentheses, 1 minus 2i. We have 2 more to do. X, what would I write? Minus, in parentheses, 1 minus I. And x, it's a positive 1, so I put minus the parentheses 1 plus I. Any questions on how we got those factors? The zeros and the factors basically are opposite signs. Let's do a little work in here. X minus 1 is just x minus 1. Let's break this one down a little bit. This would become x minus what? 1 minus 2i. Is this one going to match? Is this next one going to be the exact same thing? Because I distributed the minus in. Becomes minus 1 and minus 2i. So if we distribute this minus in, are we going to get the exact same thing? It's almost the same. X, we distribute the minus in, we get minus 1, and then minus times a minus 2i plus 2i. Brian, would you sit up, please, or stand up, if that helps. Okay, here we need to distribute that in. So we have x minus 1 plus I, because a negative times minus I is positive I. And the last one, x, you distribute the negative in, minus 1 minus I. No. We're times by negative 1, not 0. Okay, this isn't standard form yet, because our polynomial should be in descending power. How many x's are there? 5. So we need to multiply all this through. It's a little tedious, so you need to go slow. We're going to multiply all of it through so that we can get x to the 5th power and have it in standard form. I recommend starting with the conjugates. Okay? I'm going to choose to start on this side. Those are conjugates. Be very careful. What's x times x? X squared. And I'm going to keep going with the x. X times negative 1. Negative x. Please write this down with me. X times negative I. X times negative I is negative xi or ix. I guess either way is okay. Now what needs to be distributed in? The -1 needs to be distributed in. So we do another Santa hat. -1 times x is negative x. -1 times -1, positive 1. -1 times -I, positive I. Okay, and we have another one. I times x. Here's where we see some cancellations. What's I times x? A positive ix. There's going to be a cancel because it has a negative version right there. I times -1. -1i. There'll be a cancel. I times -I. -I squared. Make sure you have all this written down. Okay, I'm not going to worry about anything else on the left. I'm just going to be working with this group. We have some like terms. There's only one x squared. Are there any x's with no i's? Yeah. Negative x and negative x makes how many? Negative 2x. Okay, find another like terms. I have a negative ix. Any other terms with negative ix's? Positive ix. A negative ix and positive ix cancels out. Gone, gone. Okay, I'm just going down the line in order so I make sure I don't miss anything. Positive 1, any other integers? Not yet. Positive I, any other i's? Negative I. Cancel, cancel. And negative I squared will be a negative, what's I squared? -1. A negative, -1. Notice what happened. Every term with an I canceled out or changed to the -1. So you should not have any i's left. We have x squared minus 2x and 1 little squiggle plus 1 is 2. All of the i's canceled out because of those conjugates. Okay, let's work with the other conjugate. We should see some similarities happening. I'm going to look at these conjugates. If you go slow, then you hopefully won't make any mistakes. What's x times x? X squared. X times -1. -1x. X times 2i plus 2ix. Make sure you write small enough because we're doing 3 terms times 3 terms. We're going to be having 9 terms come out of this. And then we'll have some like terms. Now we do -1. I see a handful of people not participating, not writing things down. Okay, you need to be writing this down. -1 times x. Connor? Connor P. What is -1 times x? Connor? What? Okay, what is -1 times -1? And what is -1 times the 2i? Good. Thank you. Any questions so far? We have one more set to do. we have to distribute in the negative 2i. Make sure you always use that sign. Negative 2i times x. What would that be? Negative 2i x. Negative 2i times negative 1. Negative times negative will make it positive 2i. I'm running out of room. Okay, and negative 2i times positive 2i. Negative 4i squared. Okay, kind of run out of room there. After we get all 9 terms, what do we start looking for? Like terms. Okay, there's only one x squared. How many x's with no i's? There's another one right there. So that's negative 2x's. Here's a term with an I and an x. Any other terms with an I and an x? Right here. They cancel. Cancel, cancel. Then I have a constant. Any other constants? Not yet. Plus 1. And then I have an I, negative 2i. Is there another term with an I? Yeah, and is that going to cancel? Cancel, cancel. And lastly, I'm left with negative 4i squared. Negative 4, what is I squared? Negative 1. So the i's all should be gone. Okay, let's figure out my constants. I have 1. What does this become? Positive 4. So 1 plus 4 makes positive 5. And at the very front, we had x minus 1. Assembly. When do we get out of here? 11:05. Okay. All right. The difficult part with all those i's is over. Now all we have to do is times all these through. It's a long one. When you get a higher power, it gets longer. Okay? So just take 2 of them at a time. I'm going to choose to use the binomial. X times x squared. Shout it out. And more than just the 2 voices I keep hearing. X cubed. Shout it out nice and loud, everyone, please. X times negative 2x. Did you say negative, I hope? Negative 2x squared. X times positive 5. Positive 5x. Huh?
Can you multiply the 2 by the 2 trinomials?
You can if you want, yeah. The 5 came from right here. 1 minus 4 times negative 1, which is a positive 4. Okay, we have the negative 1 to distribute in. What's negative 1 times x squared? Minus x squared. Negative 1 times negative 2x. Positive 2x. Negative 1 times 5. Negative 5. Okay? We're going to go through and find those like terms before I multiply to the last trinomial. And then we are done. Yay! It's a long one. Okay? Are there any like terms? Yeah. So if I add up the x squareds, how many x squareds are there going to be? Negative 3 x squared. How many x to the first powers are there? 7 in total. minus 5. Yep, and now we take that and we times it to the last guy we've been ignoring for a minute. X squared minus 2x plus 2. So, if this one has 4 terms, and we're timing it into something that has 3 terms, how many terms should pop out? 12. 4 times 3 is 12, and then some of them will be like terms that you can put together. Okay, will you go through and do that last distributive property? The last distributive property, find your like terms, and then we finally have the standard form. Make sure when you're timesing x's, you're adding the exponent. X cubed times x to the second power is x to the 5th. That's fine. Yeah, I figured when you came with all that makeup on. Okay. Sorry. This is what we're doing after this. Notes. These notes. Okay, who has the first line done that's not combined? You haven't combined your like terms. You can tell me all the terms you get. Okay, go for it. Uh-huh. Okay.
7x to the power of 3.
Okay, because you're going to that one, okay. Plus 7x cubed, okay.
Minus 5x squared.
Okay.
Minus 2x to the power of 4.
Mm-hmm.
Plus 6x cubed. X 14x squared.
Mm-hmm.
Plus 10x.
Okay.
Plus 2x cubed. Minus 6x squared. Plus 14x.
Good. Who got that? Yes? Okay. That's exactly what you should get. Now if you distributed this guy into that one, you'll get the same terms just in a different order than what he did. He took this one and distributed it in, which either one works. It'll just be a different order. Now we go through and we find our like terms, and then we are done. X to the 5th will be the highest one. Look at all the x to the 4th. Add them up. How many x to the 4th? Negative 5 x to the 4th, because there's 2 terms, but one's negative 3 and one's negative 2. Then we do x to the 3rds. Ooh, there's a few of them. How many x to the 3rds? Yeah, positive 15. And then x squares, these check marks. We have negative 5, negative 14 makes how many? Negative 19 minus 6 more. Negative 25x squared. Then we have x to the 1st powers, 10 and 14. Positive 24x. And then the constant, minus 10. This is the standard form. And now if we graph this, we should see none of our roots were repeated, so we should see 5 changes in direction. Let's grab our, and I think only one of them was real, right? Let's look at the back of the top. Only one of them was real, which means we only have one that actually crosses the x-axis. Okay? So, we're going to grab our calculators, go to y equals, and carefully type this in. I would like everyone doing this, please. Get a calculator. There's calculators in the front. There's calculators in the front. Please get one. X to the 5th minus 5x to the 4th plus 15x to the 3rd power minus 25x squared plus 24x minus 10. Okay, so there's mine typed in. Let's hit graph. We might have to change our window to see it all. Yep, definitely need to change our window. Let's see. Let me play with the window for a minute, and then I'll tell you what to change it to. Negative, I'll put negative 10, positive 10, negative 20, positive 20, counting by 2s. Let's see if that works. Still not very good. Okay, where does it cross the x-axis? Where does it cross the x-axis?
What did you do for the...
The window, I put x's as negative 3 to positive 3, counting by 1s. And then the y's, I'm still not very happy on the y's, but at least we can see one of the intercepts. The y min, I did negative 20 to positive 20, counting by 2s. The scaling is what you're counting by. So we know only one will actually cross the x-axis. So there's our x equals 1, right? Notice this was x to the 5th power. Is it a U shape? No, our quadratics, x squareds, and our last one we saw x to the 4th power were U shapes. The odd functions look like these like S thingies, these squiggly S's. And it crosses, we only had one real root, which is right here, x equals 1. And it wasn't repeated, so it has multiplicity of 1, which is an odd number, so it will go through the x-axis. If it's repeated with multiplicity of an even number, it only touches the x-axis. Okay? Yes?
Wait, so how many can it have more roots? Like if it has, can one like this have more roots besides this one?
There are 5 roots, but only one of them is a real number.
Oh.
The other ones are all complex numbers. Alrighty. So what I'm going to do is extend this assignment. So we'll do questions on it next time now that we've seen all the notes. We'll do questions on it next time, and then it will be due on Thursday next week. Okay? Does that make sense? No, the honors section that we're going to talk about today. So we do a lot of time on notes. So we do next Thursday.